Welcome to the Diode channel. In this video, we will discuss a very important component in the world of electronics, namely the diode. First of all, what is a diode? A diode is an electronic component that consists of two poles and functions to rectify current. The main structure of a diode is two electrode poles made of conductor, each of which is connected to a p-type silicon semiconductor and an n-type silicon semiconductor. The anode is an electrode connected to p-type silicon, where it contains fewer electrons, and the cathode is an electrode connected to n-type silicon, where it contains more electrons. The meeting between silicon N and silicon P will form a border called the p-n junction. The workings of a diode can be explained in three conditions, namely conditions without voltage, unbiased, positive voltage, forward biased, and negative voltage, reverse biased. No voltage condition under conditions where no voltage is applied, an electric field boundary will form in the p-n junction area. This happens starting with a diffusion process, namely the movement of electrocharge from the N side to the p side. These electrons will occupy a place on the p side which is called a hole. The movement of these electrons will leave positive ions on the n side, and holes filled with electrons will create negative ions on the p side. These immobile ions will form a static electric field which hinders the movement of electrons in the diode. Positive voltage condition, forward bias. In this condition, the anode is connected to the positive terminal of the power source, and the cathode is connected to the negative terminal. The presence of an external voltage will cause the ions which are obstacles to the flow of electricity to be attracted to each pole. Negative ions will be attracted to the positive anode side, and positive ions will be attracted to the negative cathode side. The loss of these barriers will allow the movement of electrons in the diode so that electric current can flow as in a closed circuit. Negative voltage condition, reverse bias. In this condition, the anode is connected to the negative terminal of the power source and the cathode is connected to the positive terminal. The presence of an external voltage will cause ions that are obstacles to the flow of electricity to be attracted to each pole. Applying a negative voltage will attract negative ions to the cathode side, N-type, which is given a positive voltage, and positive ions are attracted to the anode side, P-type, which is given a negative voltage. The movement of these ions is in the same direction as the static electric field which blocks the movement of electrons, so the barrier will become thicker for the ions. As a result, electricity cannot flow through the diode, and the circuit is considered to be an open circuit. And that's our discussion about diodes. If you find this video useful, don't forget to give it a like, share it with friends who might be interested, and of course, subscribe so you don't miss the next interesting video. See you in the next video and have fun exploring the world of electronics.